So let's start the session. So in the last class, we have discussed about the how to treat the outliers and how to work on the when we studied the group by and cross tab. Yeah, we'll see today, Nitish. We'll see that today that cross tab and group by. Already cross tab I have explained yesterday only, right? The only thing I have to add is group by. Okay. Now, if you remember in the last class, we have completed the data cleaning. Inside the data cleaning, we have treated the missing values. How to treat the missing values was completed. And how to treat the outliers. This is also completed. These both are completed. And within the data wrangling means nothing but called as converting from one format to another format. This is called as data wrangling. Out of which the first one we have completed is encoding and how to convert the discrete categorical. How to convert a discrete categorical to discrete numerical data. And next we have seen with respect to discretization. That is how to convert with respect to a continuous variable to discrete data. And third we have seen with respect to future transformations. How to convert a skewed distribution to normal distribution. Now we are going to move on to the next one called as future scaling. The fourth one is called as future scaling. Now what is meant by future scaling? Future transformation is with respect to conversion of skewed data to normal data. Now the fourth one is called as future scaling. Now what is the meaning of future scaling? Future scaling means nothing but scaling down the data. For example, you are having a records like this. For example, one of the column is where let us take 800 divided by 1000 and 80 divided by 100, 8 divided by 10, 4 divided by 5. Everything are equal only. If you are considering only 800, if you consider only 80, if you consider 8 and if you consider 5 individually, 800 will be very high. But if you divide with 1000, the value will be the same. So here what I'm going to do is I'm going to make that scaling. Why we have to do the scaling? If you don't do the scaling, what happens? It is mandatory to do the scaling or not. Let us see this one. All these things we'll see. So here we are having assume that you are predicting the user car price. You have to predict the user car price. User car price you have to predict. Predicting the used car price. You have to predict the user car price. Now for predicting the user car price, we have to take some kind of independent variables. Means what are the variables? The price is getting dependent. So now what are the variables will be there? Means one of the variable will be with respect to years of the car. That is age of the car. How many years old car? It is 2 years old or 3 years old or 5 years old or from now. Okay, back. From now back, whether it is a 5 years old, means year of manufacturing. If the year of manufacturing is 2020, means 2 years old car. If the year of manufacturing is 2019, means 3 years old car. If the year of manufacturing is 2017, means 5 years old car. We are having the age of the car. And we are having with respect to number of kilometers driven the car was used. For example, some cars will be after 40,000, the person is selling. Maybe after 1,60,000, the person is selling. Maybe after 75,000, the person is selling. Right? Now we are having with respect to number of kilometers as one of the future. And we are having age of the car as one of the future. Now, if you go with the second one, like whether the car is having insurance, yes or no. Either we'll have yes or no, like this, yes or no. Where this is a discrete variable. For discrete variable, there is no problem. But whereas age of the car is 2.2 months, 2 years, 2 months old, or 3 years, 1 month old, or 5 years, or 6.4 years, or with respect to 1.8 years old, we are having a continuous variable. This is a continuous variable and this is also a continuous variable. If it is a discrete variable, no problem with the discrete variable because it will have either zeros or ones or maximum 2 or 3, something only will have, but there will be no much difference will be there. Whenever you are applying a concept called as distance formula, you are applying a concept called as distance between the two data points. For example, you are having the distance between this one and this one. You have to calculate the distance between this one and this one means, how to calculate the distance means square root of x2 minus x1 whole square plus y2 minus y1 whole square. Distance formula, basic distance formula. Sir, how you have got this equation? If you can remember, miss, okay. If you don't remember, miss, also not a problem. For example, you are having two data points like this. The point one is called as x1, y1. On a scatter plot, one point is there, miss, should have two values, right? x1, y1. And this is x2, y2. Okay, you are having x1, y1 and x2, y2. How to calculate the distance between these two data points? This is the distance you have to calculate, miss. First, you have to make with respect to a horizontal line on the x-axis and a vertical line on the y-axis. Now, this is the point. From here to here, what is the distance? This is the distance of here x1. This is the x1. This is the x2 point. This is the x1 point. Y point is remains same. Y point is not going to change. Y1 will be the same. Now, what is the distance between these two data points? x2 minus x1. If x2 is greater than means x2 minus x1. If x1 is greater than means x1 minus x2. Anyone. Choice is yours. If you are doing x1 minus x2 also, x2 minus x1 also. Distance will be always with respect to some value. The minus symbol indicates only the direction. But whether it is a positive direction or negative direction only. Distance cannot be negative. No distance will be negative distance. Right? So from here to here, now the y value is changing. From here to here, the y value changes, but x2 value will remain same. Now, what is the distance between these two? y2 minus y1. Now, this is a right angle triangle where you are having this is A and this is B and this is C. Everyone knows the Pythagoras theorem, that is A square plus B square is equal to C square. That is x2 minus x1 whole square plus y2 minus y1 whole square is equal to C square. C is nothing but square root of x2 minus x1 whole square plus y2 minus y1 whole square. Like that, the distance we are calculating. The distance is like this we have got. The formula is like this. This is called as Euclidean distance because Euclidean has invented this one. Right? He has invented this one. So it is called as Euclidean distance. Euclidean distance. Now here the question is, some of the machine learning algorithms are dependent on the distance formula. Some algorithms. In that, one of the algorithm is KNN. It is going to work on the nearest neighbors. K nearest neighbors is the full form. This algorithm will work on the distance formula. The max behind that algorithm is distance. Now, for example, if you calculate the distance between these records, the record number 1 and record number 2, what is the distance between first record versus second record? Means 2.2 minus 3.1 whole square plus 40,000 minus 1,60,000 whole square. Now for this square, this is negligible. You don't need to count also. 1.1 square will not be added for this one. Means indirectly you are neglecting this future and you are focusing only on the single future. So one future is dominating the other future. So it is going to be a problem in the KNN. So that is the reason we are going to do the scaling. Scaling has to be done only for only certain algorithms, not for every algorithm. Okay, not for every algorithm. For which algorithms you have to apply scaling? Means which algorithms are dependent on the distance. Sir, how I can know whether that algorithm is dependent on the distance or not? Miss, I will explain now. I will explain the max behind that, and at the time we'll discuss, right? Every algorithm will discuss the max and everything, right? At the time, if you feel that it is working on the distance, miss, you have to apply the scaling. If it is not getting dependent on the distance, miss, you don't need to apply the scaling. Is that clear? Now, here, for example, now let us take, you are going with the distance between this record and this record. These two records distance. How to calculate the distance between these two records? 2.2 minus 5 whole square plus 40,000 minus 75,000 whole square. When compared to 35,000 whole square, 2.2 whole square will be impacted. If you add also, it is negligible. There will be no difference. So one future is dominating other future, means we have to do the scaling. In that time, we have to do the scaling. So scaling is an important parameter in order to bring down the scale of the futures. So that now if you bring the scale, for example, the same example, whatever I have discussed. Now, okay, sir, you are saying the distance formula. Now, if you apply scaling, what happens? Assume I have applied the scaling. Now, what happens? I'm dividing every value with 10,000. Every value I'm dividing with 10,000. Now, what happens? This one will be 4. This one will be with respect to 16 or 1.6. 1.6 or 16? 16. Okay, this is going to be the 16 and this is 7.5. Now, square root of first two values difference is 2.2 minus 3.1 whole square plus 4 minus 16 whole square. For this value also will be impacted. It is having some impact. Assume you have divided with, instead of 10,000, you have divided with 1 lakh. Now it is 0.4, 1.6 and 0.75. Now 0.4 minus 1.6 whole square will be having the here 1 square plus 1.2 square. Both are having equal importance. Both are having equal importance, right? So once you have down the scale, every future has the same importance. That is the reason we have to do the scaling. The reason behind the scaling is this. Okay. And wherever it is getting impacted, if you feel other future is dominating this future, means do the scaling so that both of them will be on the same scale. The values will be on the same scale. Both of them are equal. Right? So for that, what are the different types of scalings we are having is with respect to one, standardization, and second one is normalization. So now scaling refers to the methods or techniques to normalize the range of independent variables. Independent variables means which are used for prediction purpose. So now you are predicting the used car price. Used car price will be dependent on which one it is dependent. On whatever the factors it is getting dependent, every factor is called as independent variables. Dependent variable is price is the dependent variable. Price is getting dependent on each and every factor. This is called as dependent variable. It is getting dependent, whereas each and every factor is called as independent. It is not depending on others. Independent means not dependency on others. Whereas price will be dependent on the factors. Based on the company name, it will be dependent. Based on the model, it will be dependent. Based on the years of manufacture, years of old car, it will be dependent. Based on number of years, number of kilometers driven, it will be dependent. Based on the whether the car is engine condition is good condition or bad condition, it is dependent. It is getting dependent on the multiple factors. All these factors are called as independent futures. Right? So all these are called as independent futures, where this is called as dependent futures. Dependent future means it is getting dependent. It is getting dependent. Whereas these are not depending on anyone. But price is getting dependent on this. So for whenever you are working on the dependent and independent variables, in the further classes, we are going to discuss machine learning algorithms. At the time, these independent variables, if one of the independent is dominating other independent variable. Now, for example, here, what are the independent variables we are having? All of them are equally importance. All of them are having equal importance while predicting the used car price initially. After that, after analyzing, you are going to decide whether more priority is given for the engineer, more priority is given for the modeler. That will be decided later. First itself, you don't know about the cars. Now, assume that you don't know about the cars. You don't know about the cars. You never have buy the used car, and you don't know what is car and car. You know car, but inside that, what are the factors? It is getting dependence on the price. You don't know anything. Initially, everyone are equal. Later, after analyzing, you'll identify which is the best one or which is the most important factor. Why I'm saying used car price? Because that is a simple example which you'll understand. If I say with this some kind of complex example, if I take and if I explain means, then there'll be no use because you'll not understand that one now. Right? Like a similar kind of, if you want to understand means, I told you earlier, that is WC. That is waist circumference versus adipose tissue. Where WC is the independent variable, adipose tissue is the dependent variable. Adipose tissue will be dependent on the waist circumference. If I say this one, will you understand? If I say this example, will you understand? So what is meant by adipose tissue, you don't know. What is meant by waist circumference also, you don't know. So then what is the use of explaining this example? So we have to explain with a simple example, which we will understand, right? So that is the reason I have selected this one. So now using this, we can understand clearly these are the independent variables and this is the dependent variable. Now, one of them should not be dominated the other one initially itself. Later we can identify, but initially everything should be the same. So in order to bring all of the futures on the similar scale, we are going to do the future scaling. And variables with bigger magnitude dominate those with small magnitude, right? The scale of the futures is important consideration while building the machine learning models, certain machine learning models, not all of them. And future scaling has to be done before the learning of the model. Means before applying the machine learning only you have to do. This is also part of data pre-processing only. This is also part of data pre-processing. Means before sending to the machine only you have to do all these things, not after the machine, right? So here, whatever the data is there, it is going to preserve the distribution. It is not going to change the distribution. For example, you are having 4, 4, 4 and 5, 5, 15, 16, 19. You are having like this. Now, if you take the data distribution from 0 to 10 and from 10 to 20, how many values are there from 0 to 10? 5 values are there. From 10 to 20, how many values are there? 3 values are there. This is the original data. Original data distribution is this one, histogram. Now, if you do the scaling, that is divide by 10. You have done divide by 10. That is 0 0.4, 0 0.4, 0 0.4, 0 0.5, 0 0.5, 1.5, 1.6 and 1.9. You have done the scaling. Now, if you apply the distribution, now you are going to take from 0 to 1 and 1 to 2. Now, how many values are there from 0 to 1? 5 only. From this one, 3 only. Whatever you are having above, the same thing will be there. The histogram is not going to change. The x-axis values will change, but the height of the number of values will remain same. It is not going to disturb the original distribution of the data. The height, everything will be the same. Only the values will be changed. The magnitude of the values will change. Is that clear? So it is going to preserve the shape of the original distribution. It is not going to change the original shape. Though you have applied the scaling also, it is not going to change. It is going to change only if you apply the transformation. With the scaling, the distribution is not going to be disturbed. Example is this one. You can write in your notes, example this one. This is an interview question. By applying the scaling, whether the distribution of the data will change or not, miss, it is not going to change. Right? Only the magnitude of x values will change, but the histogram will remain same. And the scaling will be applied only on the continuous variable, not on the discrete variable. Yeah, whether the future scaling or whether distribution of the data, will be impacted by scaling or not. Whether the distribution of the data will be impacted by scaling is the question. Answer is no. Yes, sir. Answer is no. It is not going to change. What is meant by distribution of the data means distribution is nothing but histogram. Whether the histogram will change. It is asking whether the histogram will change or not. Magnitude changes, but histogram will not change. Histogram will remain same. Right? Next. So here it is going to preserve the original shape of the data as it is. And the minimum and maximum values of different variables may vary. And preserves the outliers. If outliers are also there, outlier only will be there. For example, you are having 4, 5, 6, 7, and one of the variable is 60. How many values are from 0 to 10? 10 to 20. 4 values are there. The same 60 will be between 50 to 60. Here also will be the same. Now, if you change this one, divide by 10, if you do also, the outlier will remain outlier only. At the end only, it will remain. The outlier will not change. For this data, this is the outlier. For this data, this is the outlier. Right? So outliers also will not change. Outliers will not change. Nothing will change. Only the magnitude will be brought down. Right? Now, so here the future scaling importance will be having the more importance with respect to some of the algorithms which are highly dependent on the distance formula. Like example is K-miss. So it is not getting dependent on this one. It is going to be dependent on the gradient descent, support vector missions, K-miss, KNN, and PCA. These are the various algorithms which will be impacted. Okay. Future scaling has importance in some of the algorithms. So as of now, you don't know all these algorithm names, huh? So simply delete. Okay. So future scaling has importance in some machine learning algorithms. So for that particular algorithms, 100% you have to do the scaling. Right? Some algorithms will not have any impact. Example, linear regression. If you do the scaling also will not have impact. If you don't do the scaling also, will not have the impact. It will not change. That you will see in the further classes. When we are applying the linear regression concept, I will explain that one, right? Don't worry. Now, here, what are the different types of scaling we are having? One is called as standardization and second one is called as normalization. Standardization means converting every value to corresponding z-score is called as standardization. Bringing to z values, that is z distribution. Z, that is x minus mu divided by sigma. Converting each and every value to x minus mu divided by sigma means it is called as standardization. What is meant by normalization means min-max scalar. It is going to apply the min-max scalar. So let us see one by one. So first I am going to load the pandas and I am going to load the data set called as Titanic data set, which we have discussed in the last class, the same data set. And here I am having the age column, which is a continuous variable. So first I am going to check, is there any missing values in the age column? It is having the 177 missing values are there. First I will fill that values. Either you have to clean, either you have to drop or you have to fill. Anything you have to do. So I am filling the values and now the age column is not having any kind of missing values. Now what I am going to do is, this is the original data. 22, 38, 26, 35. These are the original data. Now I am going to apply the standardization. Standardization will be with respect to from sklearn.preprocessing, import the standard scalar. I am showing on one of the variable. Example, I am selecting one of the variable and I am showing how to apply the scaling. So from sklearn.preprocessing, import the standard scalar. And you are going to store that one in a function called as sc. Now using the sc.fit_transform. Fit_transform means fit means calculate. What you have to calculate? Standard scalar you have to calculate. What is meant by standard scalar? Z is equal to x minus mu divided by sigma. You have to calculate for each and every value. First, the overall age column is there. This is the age column. For this age column, first you are going to calculate the mu value, that is average value. And you are going to calculate the sigma value. And for each and every value, minus mu divided by sigma. You are going to do for each and every value, mu minus sigma. So like this, you are going to convert each and every value to corresponding z-scores is called as standardization. And the function we are going to use is standard scalar. Right? And like this, we are going to convert. Okay. Now here you are having with respect to age underscore sc is the new variable. This is the original variable and this is after conversion. Sir, if you want with an example, simple example. Okay, let me take with a simple example. One of the column. Example, for understanding purpose. 1, 2, 3, 4, 5. 5 values are there. Now this is the original data, some x. Now you have to apply the standardization. So calculate the what is the x bar? For this column, what is the x bar? 3. Sorry, mu. X bar means nothing but mu. What is the mu means 3. What is the standard deviation? So you are going to calculate the standard deviation. Assume the standard deviation is, example, it is 0.5. Assume. Okay. Now what I am going to do? I don't know exact value, guys. Assume only, example only. This was not calculated value. Okay. Now, how I am going to convert to standardization means now 1 minus mu, that is 3 divided by 0.5. 2 minus 3 divided by 0.5. 3 minus 3 divided by 0.5. 4 minus 3 divided by 0.5. 5 minus 3 divided by 0.5. Now, whatever the values you have got, this is the scale data. Got the point? So just you are converting each and every value to corresponding z-score. It is whenever you are writing this one, it is going to do the same. For example, I am going to create a data frame. I am creating a data frame. For example, if I open like this data set means we can't calculate each and every value. If I explain on a simple data set means the number of case studies will not be completed because you required with respect more number of data sets and real-time examples you require. But for understanding purpose, we require a small data set. I'm taking a small data set like PD of data frame like this. So what I'm going to do is I'm doing the manual calculation also. See now. And as yesterday, one of the student has told that you have went very fast and fit and transform on the variable they have not understand. Now I'll show you very detailedly slowly. Okay. For that particular student also, it will be helpful. Now, not only for that particular student, for other students also. So I'm going to take with 1, 2, 3, 4, 5. So total 4 values, 5 values, and I'm going to print the DF. This is a dictionary, na? So I'm going to create a dictionary and column. Okay. Now for this dictionary, whatever the columns are there, for this I want to apply the standard scalar. First, I'm not using sklearn. I'll use only pandas. How in pandas we have to do is, I'm going to create a new variable. The variable is with respect to df of x underscore sc. Means after applying the standard scalar, I want to get into a new column. How I will get into a new column is, the column is calculated based on df of x. Whatever the df of x is there, df of x, okay, minus df of x dot mean. Df of x dot mean. Okay. Df of x minus df of x minus mean. Divided by df of x, whatever the x is there, dot standard deviation. Dot standard deviation. Now, I'm going to create a new column. Before executing this code, first I will do manually. First I will calculate df of x dot mean separately. First I will calculate the value of this one separately. What is the mean value? So caps lock x na, it is going to throw an error. Caps lock s, 3 is the mean. What is the standard deviation? Same df of x with respect to standard deviation, dot standard deviation, 1.58. Now, what I'm going to do is, first I will select the first value, that is this one, 1 minus 3 divided by 1.58. 1.5811 is the first value, will be converted like this. Second value, 2 minus 3 divided by 1.5811. Third value, 3 minus 3 divided by 1.5811. 4 minus 3 divided by 1.5811. Next, 5 minus 3 divided by 1.5811. So let us open the calculator. Let us calculate exact values. 1 minus 3, that is nothing but minus 2, divided by 1.5811, which is equal to minus 1.2649. Okay, next one. 2 minus 3, which is minus 1, divided by 1.5811, which is minus 0.63247. This one is 0. 3 minus 3, 0. 0 by anything is 0. This one is 4 minus 3, which is positive value of this one. That is 0.63247. And this one is this one with respect to positive value. This is -2. This is +2. Only sign will change. 1.2649. So I'm going to get the values like this. If I execute this code, if I execute the code like this, okay. If I don't take the parenthesis, automatically first division will be applicable. So I have to apply the parenthesis. Now what happens means first it is going to calculate like this. Now it is going to create a new column. And after creating the new column, if I print the df, is that clear? Each value, whatever we have calculated the same values, -1.2649 and this one. This is using pandas. You have done the standardization using the pandas for this data set. For the same data set, now I'm going to use the sklearn. What I'm going to use is from sklearn, I'm going to import the standard scalar. Okay, this is using the pandas. I have shown you using pandas. Now I'm going to show you using the sklearn library. First step, I'm going to download the standard scalar. And whatever the function I have downloaded, I'm going to store in the SC. And this SC, I'm going to create a new column called as caps lock underscore SC. Earlier, whatever I have created is, oh, this one is also caps lock. Okay, this one using sklearn. Let us keep SK also, underscore SK. Means using SK. Now I'm going to apply the standard scalar on what you are going to apply? df of x column. You are going to apply on the df of x column. And you are printing the df. Print the df. Now what happens? Now the same standard scalar. In the standard scalar, what is the backend? This function is there. Na? You are calling a function. Can you call a function with no arguments? Can you call a function with no arguments? Did I told you during the functions with a function with no arguments? Did I told or no? Yes or no? Yes. A function with no arguments, a function with keyword arguments, a function with positional arguments, a function with default arguments, a function with arbitrary arguments. I already discussed, right? A function with no arguments also have discussed. And how to call a function with no arguments also have discussed. Do you remember the functions, right? And code is this one. These are the 2 lines of code will be running in the backend. So it is going to create with respect to SC. SC means just it is calculating the x minus x bar divided by standard deviation. X minus mean divided by standard deviation. If it is sample means sample mean. If it is a population means population. By default, it will assume the population only. The entire data will be considered as the population unless you take the sample. Right? So here it is going to apply the same formula. It is going to apply the same formula on the X data. What is the X data? This is the X data. Just it is applying and it is going to print. And it will give the values. Same to same. It is not going to change. The formula will be here. Just the thing is that, sir, here you have got minus 1.26 and here you have got with minus 1.41 because it is considering the standard deviation, sample standard deviation, means with respect to the square root of n minus 1. It is considering with sample, right? Now, which one it is going to consider, whether it is considering the sample or whether it is considering the population, means just you can see in the help file. For each function, you have to open with the help file. So here you can see with standardization, it is going to apply based on the mean and with the standard deviation by considering the standard deviation. So the same logic, whatever you are applying here with respect to one is using pandas, one is with respect to standard scalar. Both are same. Now here, if you apply this same thing on this large data set, whatever the data set you have considered, okay, here the data set I have applied on the Titanic data set. Now for the same Titanic data set, this is 22, right? Now for the same Titanic data set, df of age, I'm considering the df of age column, dot mean, apply the dot mean. What is the output? Okay, first df you have to execute once again. df. Now, df of age is this one, mean is this one. Similarly, df of age, the same age column. What is the standard deviation? If you calculate the standard deviation, it is 13.019. Now, for first record, what is the first record? After conversion, how it is going to convert? 22 minus 29.361 divided by 13.0196. Up to 4 decimals I am considering. So just here That is first one, 22 minus 29.361 divided by 13.0196. If you calculate the value, it is minus 0.56. You are going to get the same thing here. Is that clear? This is the original data. After converting the data is this one. What was done in the backend? Just it is calculating x minus mu divided by sigma. First it is calculating the mu value and it is calculating the standard deviation value and mu minus the x minus mu divided by sigma. What is the second value? 38. Now what it is going to do? For 38 minus, open the calculator. 38 minus 29.361 divided by 13.0196. It is 0.66. Means this 38 will be converted as 0.66. Same answer. So just it is converting. In the backend, just it is applying the formula. This function is applying the formula. Fit and transform means it is going to fit means calculate. Calculate means z x minus mu divided by sigma will be calculated. Transform means it is going to replace. Where it is after replacing, where it has to create a new variable. Since I asked a new variable, it is going to create a new variable. If I am asking in the old variable only, it has to save miss. For example, you have not written like this, then it is going to save in the old variable one. It will replace the old variable. Right? Since you have given the new one, it is going to create a new one. Right? Now here, inside this fit and transform, as one of the student has asked me a good question, that is, sir, why you are using this double square brackets? Why you are not using a single square bracket, that is age? It is why you are not using this one. So any function was designed means that function, some inputs will be given. These functions, all the functions, whatever was designed in sklearn, they are designed based on the input of data frame as the input. You should not give the series as the input. Data frame should be input. Now, if you check with respect to, just type TYP, type of df of age. If you calculate the df of age, what is the type? What is the data type? PD dot, that is core series. You are going to get the series as the variable. If you use double square bracket, that is two-dimensional array. Now it is a data frame. You have to give input as a data frame, not the series. In the fit and transform, you have to give the input as data frame, not the series. This function was created in such a way by considering the data frame. For example, def of add a comma b, c is equal to a plus b, and written with respect to c. Now here, whatever the a values are there, a should be either numeric or float. You can't give with respect to the list of values, na? Or you can't give with respect to set of values. For example, a is equal to set of 3, 4, 5, and b is equal to set of 5, 6. If I give, what is the expected answer of this one? It is going to throw an error because a and b should be the int or float. This function was created for that purpose. It is not created for adding the two sets. It is not created for adding two sets. This function was created to add the two integers or two float values or one integer, one float value. This function was created for that purpose. How you can know this function was created that purpose or not, miss? You have to read in the help file. So what you are going to read in the help file, that I am explaining here. The same thing. The help file is me only. I am only explaining that one. Me and help file both are same. For whatever the concept I am explaining. For remaining others, you have to learn. For whatever the concepts I am explaining, I am the help file. Miss, I am explaining what is there inside that, how it is considering. So all these functions are considering the data frame as the input. That is the reason you have to use the double square bracket. If you use single square bracket, it is going to throw an error called as reshape error. And it will ask you to convert to reshape of 1 minus 1 comma 1. Means from the series to data frame, you have to convert. For converting that one, directly you can use double square bracket. Simply you can use double square bracket. Automatically any series will be converted to pandas data frame by using the double square bracket. Is that clear? Now you understand each and every line? What is the meaning of fit and transform and how it is calculating? Everything is clear now. Is there any still question? First, you are going to import and you are going to save in a shortcut called as SC. Sir, if I don't use this one, I am not saving. Then instead of SC, you have to write here only the standard scalar and dot fit. Here itself, you have to write everything. Since you have taken this one shortcut into SC dot fit and transform. Right? Is that clear, guys? What is meant by fit and what is meant by transform and how it is doing? In the backend, it is just applying whatever the code is there inside that function. Simple imputer. In the backend, one code was written. What is the code? You have to calculate whatever the strategy they have written. According to the strategy, you have to calculate that one. Mean is the strategy miss, you have to calculate mean. If median is the strategy miss, you have to calculate the median. If with respect to mode is the strategy miss, you have to calculate the mode. Whatever the strategy was written inside that, according to that, everything is a function. Inside the function, whatever is there, it is going to work according to that. In the backend, it is running the code of the function only. Nothing it is doing. I told you, right? At the time of functions, I have told you that is the shortcuts. And in the future, every time we are going to use the shortcuts only. We are not going to use the lengthy process, only the shortcut. Do you remember in the functions, I have told you that one? Right? Functions are the shortcuts and it will be stored in the library and we are going to import that one and directly we will fit the data. Machine learning algorithms are also same. Machine learning algorithm theory max will be so much lengthy will be there, theory part. But coding part will be only 3 lines. Import, save, fit. Again 3 lines. The same 3 lines will be continued. Artificial intelligence also 3 lines. Import, save, fit. Import, save, fit. But inside the fit, what happens? Here, what happens in the backend? How it is calculating that one? That is, we are understanding the part. The max we are understanding. What is the backend? How it is working? We are understanding. Right? So this is called as standard scalar. The second one we are having is min-max scalar. Min-max scalar is still more easy. This is dead easy one. 1, 2, 3, 4, 5. Out of which is the maximum? What is the minimum? First, you minimum value. What is the minimum value? 1. What is the maximum value? 5. Now each and every value, x minus x min divided by x max minus x min. This is the formula you have to apply for each and every value. X is nothing but for each and every value. For loop. Just apply the for loop. So now first value 1 minus 5 divided by 1 minus minimum value. What is the minimum value? 1 minus 1 divided by what is the maximum value? 5 minus 1. That is nothing but 0 by 4, 0. So this is the original x and this is after conversion. After conversion to min-max scalar, this is the x value. 2 minus 1 divided by 5 minus 1. That is nothing but 1 divided by 4, 0.25. 3 minus 1 divided by 5 minus 1. That is 2 by 4, which is 0.5. 4 minus 1 divided by 5 minus 1, which is 3 by 4, which is 0.75. 5 minus 1 divided by 5 minus 1, which is 4 by 4, 1. All the values will lie between 0 to 1 is called as min-max scaling. The maximum value is going to be 1 only. Because you are dividing with the maximum value means how it can cross with more than 1? It is not possible now. Whenever this x value is equal to maximum value, automatically it is going to be the 1. Whenever this x value is going to be the maximum value, automatically the output is 1. For remaining values, it is going to be less than 1 only. Whenever this x value is going to be x min, automatically it is going to be 0. For x min value, it is going to be 0. X max value, it is going to be 1. So in this out of x min, this is the minimum value. So it is converted to 0. It is the maximum value. So it is converted to 1. Clear? Now the same thing, just here also, whatever the data set we are having here, that is the age column. For this age column, once again, I'm going to calculate the same. See, df of whatever the age is there, df of age dot min. What is the minimum value of the age? Means 0.2 is the minimum value. Note it. And what is the maximum value? df of age dot max. What is the maximum value? 80. Now, what is the first record? What is the first record? 22. 22 minus what is the minimum value? 0.42. Divided by what is the maximum value? 80 minus 0.42. Now this value will be converted like this. Let us calculate using the calculator. So that is nothing but, where is again calculator? 22 minus 0.42. That is nothing but 21.58 divided by 80 minus 0.42, which is 79.58. So 21.58 divided by 79.58. What is the value, miss? It is going to be converted as 0.2711. If you apply this min-max scalar, see here, from sklearn.preprocessing, min-max scalar is the function. For this function, I am going to fit the data. Data is nothing but 2, 38, all the values. What values? Age values. Age values I am fitting, and it is applying the formula, and it is going to transform. Now you have got with respect to 0.277. Same. 22 was converted like this. Now second value, 38. See 38. 38 minus minimum value is 0.42 only. Minimum value will not change. This part also will not change. Only this value will change every time. It is applying the for loop in the back end. For each and every value it is doing. That is nothing but 38 minus 0.42. What is the 38 minus 0.42? 37.58. 37.58 divided by 79.58, which is 0.47229. Same. Is that clear, guys? So 38 will be converted like this. If you are applying the min-max scalar, you are going to get the output like this. Now it is clear what is meant by fit and transform. Sorry. Yes, fit means calculate, transform means replace. Fill the values. Transform means fill the values. After calculation, whatever the values are there, you have to fill that values. Whether in the same column or different column, you have to fill. Transform means fill the values. Fill the values, replace the anything. Is that clear, guys? Scaling. Adi kuda one type of scaling. ఏదైనా కానీ వాల్యూస్ ని డిక్రీజ్ చేస్తే దాన్ని స్కేల్ డౌన్ అంటారు. అది చాయిస్ ఇస్ యోర్స్. ఫర్ ఎగ్జాంపుల్ 1, 2, 3, 4, 5 ఒరిజినల్ డేటా. Now I have shown you for the same data using the standard scalar values. I have shown you min-max scalar also values I have shown you. That is 0, 0.25, 0.5, 0.75 and 1. One type of scaling is I am going to divide everything with 10. 0.1, 0.2, 0.3, 0.4, 0.5. This is one type of scaling. This is one type of scaling. Dividing everything with 100. It is one more type of scaling. These are standard ones. Standard scalar and min-max scalar as per the statistics. ఇదేంటంటే నా ఇష్టం. ఎందుకు చేస్తున్నా అనేది క్వశ్చన్ ఏం లేదు. అది నా ఇష్టం. Whereas these min-max scalar and standard scalar as per the statistics and dividing with 10. Why you have divided with 10 only? You can divide with 8 na. You can divide with 7 na. We can divide with 14. Anything you can divide na. Choice is yours. That is your way. That is not statistics. This is statistics, where statistics has with respect to standardization. Already you have seen that Z distribution. What is meant by Z distribution I have told you, and already I have completed that one in the statistics. Now you are applying the statistics and scaling, right? So that is called as standard scalar. And whereas min-max scalar is one more statistics where everything you want between 0 to 1. Why 0 to 1 only? Because the probability lies between 0 to 1. That is also statistics. The word of probability comes into picture. These both techniques are as per the statistics wise. Other than this, if you apply anything, is not statistics. That is your choice, your way of own way. Is that clear? Clear, guys? That is with respect to the scaling. Any questions on scaling? Scaling is clear for everyone. Scaling is clear, and from sklearn, whatever the function you are going to import, and using that function, import the function. And for that function, you are going to take with respect to fit and underscore transform on the variable. And you are going to give the variable, whatever the variable you want to fit. Means you want to calculate for which variable you want to calculate, that variable you have to write here. Right? So just for everything you are going to import and fit. It is only to calculate. Automatically in the backend, one code is written and it will do. For simple imputer, one code is there. For outliers, one code is there. What is outlier code? Winsorization technique. Winsorization. Winsorizer is the function. What is the code they have written in the backend? First, it will calculate the Q3 minus 1.5 IQR. Using the pandas, it will calculate. First, it will calculate the Q3 separately using the pandas. It will calculate the Q1. After that, it will calculate the Q3 minus 1.5 into IQR. And it will keep the name as LC, lower cap. And Q3 plus 1.5 into IQR. Q1 minus 1.5 into IQR. This is upper cap. And this is the lower cap. And what it is going to do, just wherever the values replace, wherever the values is greater than UC, replace with UC. Wherever the values less than LC, replace with LC. This is the backend code of the winsorization technique. Whichever the value is less than this should be replaced with this value. Whichever the value is greater than this, it has to be replaced with that. It is either using the df dot replace is one option. Second option is np dot where is one more function also available. And these two functions you'll see in the further, slowly, one by one. Right? So just it is applying the concept of replacement. Wherever the value of greater than upper cap, more than upper cap value, whatever the value is there, it is considered as an outlier. So the outliers will be replaced with the upper cap values. Whichever the lower than this is considered as a lower outliers, and lower outliers will be replaced with the lower cap. In the backend, one pandas code was written. But simply, we have calculated only import, fit and transform. We have imported, fit and transform, we have done. But actually, we have to write 4 to 5 lines of code separately. But that 5 lines of code, instead of shortcut, we have brought by using a function. For imputer, shortcut is there. For outlier, shortcut is there. Scaling shortcut is there. Transformation is there. Transformation, no need of shortcut. Directly one line of code in. For one line of code, no need of shortcut. If you import also, import only will take one line, right? Import and fit and transform, 2 lines of code, waste of time. Instead of that, directly you can transform using one line only. So scaling you are having and encoding you are having shortcut, and at the same time, discretization also you are having. So wherever the multiple lines are there, when more number of lines are there, you will require the shortcut to bring to one line. If the code itself one line is there, miss, why the shortcut for that? Shortcut also one line only, code also one line. Then what is the use of shortcut? So for that one line of code, we no need to create the functions.